All right. Ready? Here's the deal. I put the unit circle down. I've got all your ordered pairs. Remember the radius is 1. Okay, so this is what? 1, 0, and then 0, negative 1, negative 1, 0. What's this one? 0, 1. Okay, I put some 45s down. I put a 60 and a 30 down, but a 60 is what I have. Okay, so let's graph y equals 10. It's going to look different. You guys are used to this, right? This is sine and cosine, right? Yeah. Tangent looks different. All right, y equals tangent. Okay, first answer that question. What's y equal tangent of what? 0. I put it in degrees first. So if you look at 0 degrees, you're right here. Now remember, tangent is just what over what? Y over x, correct? So which one's y? 0. Which one's x? 1. So what's 0 over 1? The answer to this is 0. The answer is 0. Tangent at 0 radians is 0. 0, 0. So you kind of know already, hey, there's my point. You already know that. Tangent 45. Look right here. Here's your 45. This is a 1. This is a negative 1. This is a negative 1. That is not a negative 1.
It's a positive.
Doggone it. This is negative. This is 1. This is negative 1. That's a positive. How about if I just do this?
There you go.
Okay. What's tangent at 45 degrees? Y over x. It's what? 1. So if I put in 45 degrees, I get out 1. Now remember, 45 degrees is just pi over 4. Okay, what if you put in negative 45 right here? This one. You get negative 1 over 1. The answer is what? Negative 1. Put in 90. Here's 90 up here. Y over x. What is it? Because it's what?
It's 1 over 0.
Yeah, this is going to be 1 over 0. And 1 over 0 is what? Undefined. Okay. What about negative 90? Oh, right here. Still undefined, because that's going to be what? Negative 1 over 0, still undefined. Okay, then I threw an oddball in. What's tangent at 60?
Square root of 3.
Yeah, it's really, if you look at it, square root of 3 over what? 1. Right? So a square root of 3 is the answer. Which is roughly 1.73. I'm sorry how small this is getting. You people in the front row, you have the best seats in the house. Okay, you guys ready? Can we graph it? Okay, we already know 0 goes in, 0 comes up. Let's talk about these undefined ones right here. These are kind of special. If you put in 90 and negative 90, you get out undefined. What's that look like?
It's not there.
It's what? It's not there. You're right. There's no answer at 90 and there's no answer at negative 90. So what do we do?
Open circle?
Asymptote. There it is. So at 90, and by the way, I'm going to go back to radians, and at negative 90, you get these asymptotes, right? There you go. There's no answer at 90, and there's no answer at negative 90. But there is an answer at 0. 0 gets 0. Okay, what's dead center, guys? Dead center. What is it? Pi over 4, right? But pi over 4 is 45 degrees, and you already did 45. It's what? It's 1. So I'm going to go up 1 right here. But what about dead center here?
Negative.
Negative pi over 4. And that's negative 45. What's the answer? Louder.
Negative.
It says negative 1. Yeah, negative 1. Right about here. So it goes from here to here to here. Oh, okay. I made you do another one. I made you do what? 60. So 60 is a little past 45. It's about here. So at 60, what's the answer?
Square root
Square root of 3, but that's really 1.73. So look at this, guys. That's how it's looking so far. So does tangent get extremely big? I'm at 1. I'm at 1.73. Is it going to get to 5? Is it going to get to 20? No guesses? Okay. Okay. All right, fine. You're not going to guess. Watch this. All right, here we go. Here's a triangle for you. Estimate that angle. Estimate. You think that's a 70? Oh, I go more 80-ish. Okay, if you have tangent of 80, you have this side, whatever that is, over this side, whatever that is. Punch that in. You don't know it, just punch it in. What's tangent of 80? So you guys got to know this. Tangent. Oh, is it 5.67? Okay. So tangent of 80 is 5.67. Okay, well guess what? That means at 80 degrees you're going to go where? 5.67. Does it get bigger?
Yes.
Of course it does, guys. What if I went like this? What if I did this triangle? Okay, this might be what?
97.
Give me an
87.
angle. 87? Okay, 87. Somebody punch in tangent 87.
19.1.
Okay, so tangent of 87 is 19.1, I guess.
0.8.
Does it get bigger?
Yeah.
Hit 89.7. Tangent of 89.7. Almost 90. 89.7. What?
191.
191. Does tangent get awfully large?
Yeah.
Yes, it does, and that's why it rides where? Where's it ride? Right next to the vertical asymptote. Right next to it. It just goes skyrocketing. It also goes way down too. So I can't go down, guys, but it rides the vertical asymptotes. Okay? Okay. Well, here's the deal. You're actually done. That's it. That's what tangent looks like. So can I ask you this question? From here to here, the whole thing is done on paper. So this becomes the period of tangent. How far is this?
Pi.
Half a pi? Half a pi is? Pi. So guys, tell me where the next vertical asymptote is. The next vertical asymptote is?
3 pi over 2.
Yes. Half a pi would get you to pi. Another half pi would get you to what?
3 pi over 2.
3 pi over 2. What's this right here? Okay, what's between 1 half pi and 3 half pi?
Pi.
Pi. Okay, I'll put this on your paper. Ready? Let's graph between here and here. Okay, dead center. You put in pi, your answer is going to be what? Look back here. Yeah, look back here. 0. Okay, dead center between here and here. Right here. What's the answer going to be? 1. Same answer. Dead center between here and here. -1. Is it going to do the same thing? Sure it is. There it goes. Now I could keep this going, guys, right? I'm not going to, but I could. What would be the next one after this?
5 pi over 2.
5 pi over 2. What's the next one? 7 pi over 2.
9.
9 pi, 11 pi. Oh, okay, got it? Are we good?
Yep.
Because I got to slide down now. You okay? All right. Where is it? Right there. Delete. Okay, now I'm sliding down. Answer these questions. What is the period of tangent? We already kind of talked about it. I hope you agree. Okay, what's the domain?
-5 over 2 to 5 over 2.
Okay, no. Domain means what can I put into tangent and get an answer of? Is it in everything? Except? anything can go in. I can get answers for anything, except, where did you have those vertical asymptotes?
Zero.
Nine.
Except what?
90.
Is it EX?
Yeah,
Yeah.
Sometimes when you spell, do you ever spell an easy word and go, how come this doesn't look right?
EXC.
Okay, anyways, except what?
90. Negative.
Okay, watch.
Pi over
Pi over 2,
no. Negative pi.
3 pi over 2.
The pi's over 2.
What kind of pi over 2?
Pi over 2 plus pi.
Odds. Isn't it odd? Except odd multiples of what? Pi over 2. So when I say except odd multiples, I mean 1 pi over 2, 3 pi over 2, 5 pi over 2. You get it? Right? Okay. How about tangent? We got to talk about this. Tangent of theta is what kind of function? And the word is? It's always going to be a what? It's an increasing function. And you might want to draw a picture, but this is increasing. From left to right, it goes what? It goes up. You don't have to draw a picture because you see it up above. Okay, where does tangent start?
Negative.
Always starts where? At negative pi over 2. Where does it end?
Pi over 2.
Pi over 2. Unless, now this is important, unless you get tangent of, I'm going to make one up on you, let's go this, minus pi over 4. Do you know what just happened?
You shifted it.
I shifted it. Which way did I shift it?
Right. Pi over 4.
Right pi over 4. So if you shifted right pi over 4, how do we do this again? How do we do this? We take that pi theta minus pi over 4. We set it equal to the starting point, negative pi over 2. And we solve it and get, what's the answer?
A number.
Negative.
Negative pi over 4. Yeah, now you start at negative pi over 4. And then you just do what we did. Dead center, 0. Between the dead center and the asymptote. Up 1, down 1. It's that easy. Okay, what about the end point? Take this, set it equal to the end point right there, pi over 2. Now what? You add pi over 4 and get
3 pi over 4.
3/4. So this is where you end. Okay, that's the only reason this is tough. This is only tough because you don't always start here and here. You have to pay attention to horizontal shifts and compressions and stretches. They get nasty. But that's so easy to solve, isn't it? Okay. I took a lot of time on tangent because I had to, because you guys didn't know enough. When we go to cotangent, it's going to get easier. Okay? Are you ready? Okay. Matter of fact, you can answer those questions while I get ready. Okay, probably good enough right about there. Remember, cotangent is x over y, it's not y over x, so it's basically the reciprocal of tangent. So let's do 0. 0's right here. Give me x over y. 1 over what? 1 over 0, which is? Oh, undefined, right? At 0. Oh, right now, this is what I know. I put in 0 radians, what do I get up?
Nothing.
I get nothing, but really nothing means
Asymptote.
a vertical asymptote, okay? Keep going. What's cotangent at 45, if you can look at that one? It's 1. The answer is 1. What's cotangent at 90? 90 is way up there. It's what? It's 0 over 1, which is 0. What about 135? That would be this triangle. It's -1. Yep. What about pi or 180 right here? Isn't it -1 over what? 0? But that's what? Undefined. Got it. Okay, so here's 0. 180 is right about here. I'm going to put pi instead. And you know there's no answer, so it's vertical. Vertical here. Okay. Guys, cotangent is so easy because it's the same as tangent, except
Opposite.
reciprocated. So, here's the deal. If I go to the dead center, that's going to be pi over 2. You already know the answer. Look, over there. 90. Pi over 2, the answer is what? 0. If you go to the middle of the asymptotes, the answer is 0. Okay. When you go from asymptote to the middle point, right here, that would be pi over 4, right? Okay. Okay, we already did pi over 4. It's right there. The answer is what? 1. Here's 1. Up, up, up. There you go. This would be 3/4 pi, wouldn't it? Okay. Well, at 3/4 pi, which is really this angle right here, 135, you get what? You get 1. Right about here. Okay. Do you want me to do more points? Do you know what it does after this point?
It goes up.
It rides up. Okay, what does it do here?
Rides down.
Rides down. Okay, and then it goes zip, zip, zip. There it goes. Okay. So doesn't it look like tangent? Except what? Oh, you're kind of right. It is a reflection, but let's not say it that way. Remember how I said tangent is a what function?
Increasing.
Tangent increases where cotangent is a decrease. So it's you're right, Chris, but you're not quite right, Chris. You know why? Because the asymptotes are in different spots. So it really is not a reflection. I mean, I get what you're saying, but if you actually compare the two graphs, it's not a reflection. Anyways, somebody tell me where the next vertical asymptote is.
It's
At 2 pi. Yep. Okay. And you basically do this, right? And then you go here, here, and you just do this. Okay. Where's the next vertical asymptote?
3 pi.
3 pi. Next.
4.
5, 6, 7, 8. Okay. Got it? All right. Answer the questions below if you can, and then I will catch up to you. Okay, here we go. Period. What's the period of cotangent? Pi. Okay, what's the domain? I can put any angle in, right? Except what?
Except
What? Multiples of pi. Just say multiples of pi. Okay, multiples of pi. When I say multiples of pi, I just mean 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, like that. That because every one of those is a vertical asymptote. Tangent. Oh, sorry. I messed up. There's always a mess up. Here it is. Cotangent of theta is a what kind of function?
decreasing.
Decreasing. Okay. Period. Okay. Okay. Cotangent starts where? When I say starts at 0, I mean has a vertical asymptote at 0. It ends where? At pi. Unless what?
It shifted.
There's a shift going on. Okay, so let me throw one at you. Cotangent of, boom, 4 theta. Do you know what that did? What does 4 theta do to the function?
Oh, wait.
Compresses it.
That's a compression. What kind? It's inside your principles. It's horizontal compression. If it's a compression, it's really going to make the period what? How much shorter? 1/4. And you can probably do that in your head, but I'm going to do it by setting them equal. Okay, here I go. You might want to do this. Take this number inside, set it equal to what? 0. Set it equal to what? The end point, pi. Okay, so where are we going to start? Divide by 4. What's the answer? We will start at 0. You'll have a vertical asymptote at 0. But your vertical asymptote, that's usually is at pi. Guess where it goes? Comes in and it becomes what? Pi over 4. So basically, all those vertical asymptotes, they get compressed 1/4 of the way in. Now they're 1/4 pi apart, and another 1/4, and another 1/4. You know what I'm saying? Say yes, say no.
Yes.
Any questions?
No.
Turn the page. Now let's do what? Is it cosecant or secant? I can't remember.
Cosecant.
Okay, cosecant. Okay. Hang on. Okay, cosecant. Okay, got it. That's good enough. Okay, here we go. Okay, let's graph y equals cosecant of theta. Oh, and guess what? We're not done. What are we gonna do? We're gonna do the what function? Whoa. We're doing the reciprocal function. If they tell me to do cosecant of theta, no, I'm gonna do sine of theta. And I'll show you why. I'll give you 30 seconds. You guys should know, that's the parent. Put the parent on paper, go. This is something I've already tested you on. What's that? No, just don't look here. Don't look here. Just graph what? Just graph sine. Do not look anywhere else. Just graph sine. Sine has a period of 2 pi. And then sine starts where? At the maximum 1 or the minimum -1 or 0? Okay, 0. Okay, it's positive sine, so we're going to go where? Maximum first. Then where? Not minimum.
0.
Back to the midline or 0, yep. Then where? Minimum, then where? Midline, then where? Max, then where? Midline. So guess what? This is pi, this is 2 pi, this is what?
3 pi.
This is 3 pi. Okay, there it goes, here, here, here. Actually, it goes here. This would be negative pi. Okay. You okay with that? That should not have surprised you, by the way. That is sine. Is that what I wanted? No. I want what? Cosecant. And cosecant is simply what? The reciprocal of sine. So whatever answer sine gave you, flip it. Sine is y over r, so we're going to do what? R over y. Okay. But guys, you don't have to think that hard. Watch this. You ready? See this answer right here? 0 goes in, 0 comes up. 0 radians go in, 0 comes up. This is the number you concentrate on right here, the answer. If the answer is 0, which is 0 over 1, by the way, flip it. Flip 0 over 1. 1 over 0. Oh, it's undefined. Cosecant of 0 degrees is undefined. Okay, let's go do pi over 2. What's this point right here, guys? That point is pi over 2 comma what? 1? Okay, take this number, the answer, and flip it. 1 over 1, if you flip it, it's still 1 over 1, isn't it? Didn't change. Cosecant of pi over 2? 1. Yes, no? Take the answer 1 and reciprocate it. 1 over 1, flip it, 1 over 1. Same answer. Okay, what about pi? Pi, comma, what? 0. Oh, there's the answer. 0. Flip 0. 0 over 1, if you flip it, is 1 over 0. Undefined. You are noticing a pattern. Okay. How about 3 pi over 2 right here? This would be, this is 3 pi over 2, comma, negative 1. Flip negative 1. Negative 1 over 1, flip it. Negative 1 over 1, it's negative 1. 2 pi, right here. This is 2 pi comma what? 0, flip 0, guys. 0 over 1, flip it. 1 over 0. Undefined. Oh, okay. So every time you said undefined, what does that mean? Those are your asymptotes. Yeah, yeah. Okay, now we're getting somewhere. Here we go. So every time at 0, you said, oh, wait, okay. And here you said, right? At pi you get undefined. At 2 pi you get undefined. So where do you get undefined, by the way?
On the pi.
Whenever the answer is what to sign?
Pi.
Whenever the answer is 0, 0, 0. If you flip 0, you get undefined. So every time it touches the x-axis, you're going to have what? An asymptote. Okay? So where's the next asymptote?
3 pi.
At 3 pi. Okay. So now, we're not done. We got to get cosecant. Well, where's cosecant going to be? All right, you ready? You have to think like this. I know cosecant of 0 is what? Undefined. So that created this. I know cosecant of pi over 2 is what? 1. See, that point is on cosecant. And that point is on sine. So here's where sine and cosecant are equal to each other. Well, now watch this. Keep going down the curve, right about here. What's the answer for sine? About what? Half. Right about there, the answer is half. Okay, what would it be for cosecant? 1 over 2, flip it. Cosecant at this spot right there would not be 1/2, it would be what? Flip it, 1 over 2, flip it, 2 over 1. You're there. So do you get what just happened? 1 over 2, if I reciprocate the answer, you're here. But guys, let's get closer and closer to this point right here. Let's get here. Give me a fraction that might be. This is 1/2. Give me something here. 1 what? 1/4. Okay. Well, reciprocate 1/4. What do you get? 4. Now you're way up here. Look at this. It shoots straight up the vertical azimuth, right? Well, guess what it's going to do over here? It's going to do the same thing, right? That is cosecant. Cosecant just shoots up wherever the peak happens. It shoots up from the peak. What do you think it does here? It just shoots down. And then we're back here. Now what? Up, up, and it just repeats and repeats and repeats. And this one right here, down and down. So the black one is the answer. Not the red one, the black one. The red one is sine, the black one is cosecant. So I tried to paraphrase what I just did. So go down below and read that and tell me if that makes any sense to you. I hope it does. So delete, copy, select all. Okay. And here it says delete. Okay. So what I said to you is this. So when graphing y equals cosecant of theta, just graph what? Y equals sine of theta. Then find the vertical asymptotes. Where do you find them, by the way?
The pi's.
Well, in this one, yes. But wherever the graph hit the what? Hit the x-axis. That's the vertical asymptote. Okay. From there, look for your peaks, look for your valleys, draw parabolas up or down. Did I do that up there? Sorry, I can't point, but I think I did that.
Yeah, you did.
Okay. Then the last comment was, when graphing secant, just do what? Just graph cosine. And then repeat the same process you just did here. I don't want to do that because it's the same thing. Is that okay? All right. All right. So that was 3 pages of notes. How'd you do? You think you're okay?
Yeah.
All right. We got 20 minutes. Let's see if you're okay. Period 5, we just started this time. I did not give them graph paper because I just feel like I think you can make your own graph. Okay? 15. Number 15. I'll give you a 1 minute head start. See if you can get it on paper before I get it on paper. Okay? All right, I'm shutting this down. You guys are okay? There's nothing I can show you anyways because it's all gone anyways. All right, you got a 1 minute head start.